Welcome to the DIY Honda Garage channel. The DTC P0115 indicates an issue with the Engine Coolant Temperature, ECT Sensor 1, which has reported a reading that is out of range. This sensor plays a critical role in monitoring the temperature of the engine coolant to ensure optimal engine performance and efficiency. Located typically near the thermostat housing or cylinder head, the ECT sensor helps the engine control module, ECM, make timing adjustments and fuel calculations based on coolant temperature. In this case, the signal for ECT Sensor 1 is not within the expected operational limits, suggesting issues with either the sensor itself, its wiring, or its connection to the powertrain control module, PCM. Diagnosing this problem begins with verifying the parameters using Honda Diagnostic System, HDS. The ECT Sensor 1 is instrumental in providing real-time feedback about engine coolant temperature, which is essential for regulating engine performance and emissions. Located typically at the engine's thermostat housing, this sensor uses a thermistor to vary its resistance based on the temperature of the coolant. If the coolant is too hot or too cold, the ECT sensor sends a voltage signal to the PCM for corrected action. Specifically for DTC P0115, the sensor's signal falls outside of standard operational thresholds, which can lead to poor engine performance or even engine damage if not addressed vigilantly. The DTC code indicates a malfunction that needs urgent attention, and it's crucial to diagnose the root cause to restore correct operation. Several factors could lead to the triggering of DTC P0115. A faulty ECT Sensor 1 could provide readings that deviate significantly from the expected values due to internal malfunction, impacting the signal sent to the PCM. Additionally, wiring issues such as frayed wires or corrosion can impede proper signals from reaching the PCM. Poor connections at the ECT sensor or PCM can also be culprits, leading to intermittent or complete signal loss. Each of these potential causes must be systematically investigated to ensure a comprehensive troubleshooting approach. Prioritizing these checks allows for identifying the underlying issue efficiently and accurately. The symptoms arising from DTC P0115 can vary, but typically include noticeable engine performance issues, such as poor acceleration or stalling. Drivers may also observe the check engine light illuminated on the dashboard, which is an indication that the vehicle's onboard diagnostics have detected a fault. Additionally, increased fuel consumption is common because the engine may run richer due to incorrect temperature readings affecting fuel-air mixture ratios. These symptoms not only impact driver experience, but also indicate underlying issues that may affect vehicle safety and efficiency, necessitating immediate troubleshooting. In the first troubleshooting step for addressing DTC P0115, begin by setting the vehicle in the on mode, which powers electrical systems without starting the engine. Utilize the Honda Diagnostic System, HDS, to examine the ECT Sensor 1 value. The expected signal should register less than 0.14 volts. Clear analysis of these readings is critical. If they meet the threshold, it confirms that the problem is persistent, allowing further investigation to continue. Conversely, if the observed values are above this threshold, it may suggest an intermittent failure, which necessitates checking for poor connections or loose terminals between the ECT sensor and the PCM. Always ensure that readings are taken under consistent conditions to ensure accuracy. Upon confirming the initial condition from the first troubleshooting step, Step 2 requires again turning the vehicle to the on mode. At this stage, check ECT Sensor 1 reading again, this time looking for a value greater than 4.99 volts. If this condition is confirmed, it indicates a duplicated failure, moving forward to the specific investigation outlined in Step 5. If the threshold is not met, it indicates that there may be an intermittent issue present. In this case, it is critical to inspect for loose connections or poor wiring that could be affecting the ECT signal, and to utilize any recorded snapshots from the onboard diagnostics to reproduce the failure behavior in similar conditions. In Step 3, the troubleshooting process focuses on isolating the ECT sensor to verify its functionality. Start by transitioning the vehicle to the off mode and disconnect the ECT sensor 1 2P connector. Next, return to the on mode and recheck the ECT sensor 1 signal using the HDS. In this case, you are looking for a reading that is again less than 0.14 volts. If the threshold is met, it confirms that the ECT sensor is likely the source of the problem, leading you to Step 4 for further diagnostics. If the assumption does not hold, the investigation will necessitate checking other related components or wiring to find the cause of incorrect readings. Step 4 entails conducting a critical check for any shorted wires linked to the ECT sensor 1. Start by ensuring the vehicle is off. Then use the HDS to jump the SCS line, allowing it to sit for over a minute. Once this setup is complete, disconnect the PCM connector E, 80P. You will then need to check for continuity between specific test points, the female terminals of ECT sensor 1, number 2, and the vehicle's body ground. If continuity is confirmed, it indicates a short in the TW wire connecting the PCM and ECT sensor, leading to necessary repairs in that area. If there is no continuity, it suggests the TW wire is intact, necessitating further investigation or potential replacement of the PCM. In this step, you will again focus on checking the ECT sensor 1 by bypassing its terminals to evaluate the sensor functionality accurately. Begin by ensuring the vehicle is off before disconnecting the ECT sensor 1 2P connector. Connect a jumper wire between terminals A and B on the ECT sensor 1 connector. After establishing this connection, switch the vehicle back to the on mode. You will again monitor the HDS for the ECT value, looking for it to exceed 4.99 volts. If this condition is observed, then it reinforces the integrity of the wiring, leading to an acknowledgement that the ECT sensor likely is faulty and may need to be replaced. If the threshold doesn't match, it suggests deeper issues and could lead back to the wiring or PCM for inspection. Step 6 of the troubleshooting process involves measuring voltage to assess whether the ECT sensor circuit is operational. After ensuring the vehicle is off, remove the jumper wire previously used from the ECT sensor 1 2P connector. Then, put the vehicle into the on mode and check the voltage between the designated test points. The expected reading at this stage should be roughly 5.0 volts. If this voltage is present, it suggests that the wiring and connections are functional at this point, allowing you to move forward with diagnostics. If the readings differ, however, it indicates further exploration is necessary, potentially pointing to deeper, underlying issues affecting the ECT sensor's signal. Step 7 prompts another check focused on the system's wiring integrity, specifically the SG2 line. To execute this, begin by ensuring power is disabled and connect the SCS line with the HDS again for over a minute. Following this, you will need to disconnect PCM connector E, 80P, and check the continuity between the female terminal of ECT sensor 1, number 1, and PCM connector E, 80P, number 78. Finding continuity indicates that the SG2 wiring is solid, and you can either consult service manuals for any DTC-related queries, or potentially consider substituting with a known good PCM for further diagnostics. However, If continuity is absent, it signals an open circuit, necessitating repairs to the SG2 wire between the ECT sensor and PCM. The final troubleshooting step involves verifying the integrity of the TW line, following a similar process to previous techs. Start by ensuring the vehicle is off. Then jump the SCS line with the HDS and allow it to stand for more than a minute. Next, once the PCM connector E80P is disconnected, you will check for continuity between the female terminals of ECT sensor 1, number 2, and PCM connector E80P, number 52. A finding of continuity suggests that the TW wiring is functioning as intended, allowing for a protocol of double-checking service information or considering additional diagnostics. In contrast, if the circuit is not continuous, you will need to repair the TW line to restore proper communication between the PCM and the ECT sensor. After completing the necessary repairs associated with DTC P0115, it's essential to verify the effectiveness of the work completed. Start the verification process by clearing the fault code through the HDS. After this action, monitor the vehicle's onboard systems to ensure that the check engine light does not reappear. Conducting a test drive is crucial. It allows you to assess the engine under typical driving conditions to see if performance issues, such as hesitation or stalling, have been resolved. This thorough check is integral to confirming that both the repairs and the underlying causes have been successfully addressed, leading to the overall reliability of the vehicle's engine performance. To prevent the recurrence of issues like those associated with DTC P0115, implementing routine preventative maintenance is fundamental. Regularly inspecting the connections at the ECT sensor 1 and the PCM will identify any potential issues before they escalate. Inspecting the wiring for any signs of wear, fraying, or corrosion will greatly enhance the longevity of the sensor's functionality, thereby safeguarding the engine from related temperature issues. Additionally, sourcing quality replacement parts during repairs ensures compatibility and performance. Following these maintenance protocols will significantly reduce the likelihood of sensor-related faults, enhancing overall vehicle reliability. In summary, DTC P0115 indicates an essential fault with the Engine Coolant Temperature Sensor 1, which plays a pivotal role in engine management and performance. Systematic troubleshooting, from verifying readings to checking wiring integrity, proves necessary for pinpointing the exact failure point. It is crucial that the ECT sensor's performance and connection to the PCM are monitored regularly to prevent emergent issues that could impact vehicle operation. Drivers should be proactive in responding to DTCs, acting quickly to investigate codes as they arise, to ensure that their vehicle operates safely and efficiently, preventing expensive repairs down the line. Please like and subscribe to the channel. See you next time.